Hi guys. A while ago I was studying for my semester examination. That's due in about 3 weeks' time. And I was reading this big book that had a lot of theory in it, kind of dangerous and very scary theory. And there was a position that clicked to me that I could not go any further. I did not understand the theory properly, and I tried going back, read again, and it still had problems. I went to the internet, searched, and well, the problem did not seem to resolve itself. So I was like stuck, and I thought, what the heck? And I went to listen to some music. And just then it clicked to me that, well, I didn't talk about exceptions in Python. So, what are exceptions? An exception is a situation or an event that a program will encounter, and it kind of cannot cope up with it. It cannot determine what to do next. Because computers are not generally intelligent like we are. If they kind of come across something that they cannot cope up with, or they cannot decide what to do next, what they will do is they'll kind of either shut down the program, or if it's kind of system-wide error, it'll kind of shut down the computer. So this kind of unexpected behavior, unexpected termination of programs is kind of unlikely or not entertained by users. So it's kind of very important that you handle exceptions properly. So where can these exceptions occur? Well, exceptions generally can occur in a lot of places, but the most common places are like you try to do some mathematical operations, and all of a sudden you divide a value by zero. So if you divide a value by zero, you should get infinity. Well, mathematically, the way computers operate, they cannot generate an infinite value, and that will cause a number error. Also, if you're trying to kind of open a file that does not exist, remember we talked about files the last session, it'll kind of say, well, the file is not there and we cannot handle it. That kind of error is like I/O error or input-output error. And also, when you try to write to a file without sufficient privileges, it'll also cause an error. And even when you work with strings and tuples, etc., you kind of can cause errors. So this kind of errors will cause the program to terminate if they're not properly handled. So if I just open Python idle and show you some examples. Yep. So the first thing I'm going to do is I'm going to divide a value by 0. I just divide it by 0, and kind of come across a 0 division error, and it says division by 0. So if I say I try to open a file that does not exist, open crazy file, and with the read permission, it says, well, no such file or directory, crazyfile.txt. So what happens is whenever these exceptions are kind of thrown or encountered, the program will terminate. And if you kind of doubt it, I'll say like just say for I in range minus 10 to 10, I'm going to say print 100 divided by I. Okay, I think I'll just reduce this range from minus 5 to 5. And let's see. So it kind of went until I is 0, that is 25, 20, 33.33, and likewise. And when I was 0, it kind of makes infinity, and thereafter it causes division by 0 error and does not continue. So if it did continue, you should have some positive values. If 100 is divided by 1, you should get 100, positive 100, then positive 50, 33.33, likewise. But it didn't. That's because once it encountered this error, the program terminated. And this is kind of undesirable effect, and we should always try to prevent such things happening. So what we do is, normally we kind of enclose these dangerous lines of code or kind of suspicious lines of code that could cause exceptions in a try block. So a try block is something that you say just try, put colon, and then add the lines of code that are kind of suspicious. And now you know that you kind of can generate certain type of exceptions. For example, if you're doing a division, you can accept the zero division error or any other kind of error that encounters with numbers. If you're working with files, probably you can end up with an IO error. So what you do is you say except, and you put the error name over here. Let's say, or it can be IO error, and you can also say something like this as E or error message. And what it'll do is it'll kind of take the error, it'll handle the error, and will take the message as well. For example, over here we say IO error, error number 2, no such file or directory, crazy file.txt. So this is the message and this is the error. So if you want to kind of get the message as well, for example, we want to record all the errors that occur, we can use something like except error, for example IO error, as error message, and kind of lock this message altogether. And if you kind of can accept multiple errors, let's say you can have a division by zero or zero division error as well as IO error, you can kind of put both of them into the same try block if it's necessary, but I don't think it's kind of common thing that happens. And you have this else part and the finally part. These are kind of not necessary, but it's kind of need to have them. The else part is executed if and only if there has not been any exceptions in this try block. So if there was an exception, this section will not be executed, and if there hasn't been an exception, this will be executed. But the finally block or anything under the finally block will be executed regardless if there has been an error or not. So this finally block will be executed, and this else block might be executed depending on if or not there has been an exception. Okay, now if we go to our Python GUI and just try things out, I'm going to use the same example that we used over here, which is a for statement which has a division that can or that will kind of generate a division 0 error. So what I'm going to do is, first of all, I'm going to declare two variables. One of them will record the result and one of them will record any error. So it's going to be like result list equals an empty list, and I'm going to say error list equals, it's also an empty list. And after that I'm going to use this for statement as usual. I'm going to say for I in range -5 to +5, and thereafter comes the kind of suspicious code. So I'm going to use a try statement. I'm going to say try colon, and when I enter, I will be within the try block, which is kind of a safe place to put suspicious or dangerous code. So what I'm going to do is I can just I'm going to use a variable named val equals 100 divided by I, and I'm going to say print val. So it's kind of the same thing that's happening over here. What I did was I used a variable named val over here. I stored the result into the variable and kind of printed it, and thereafter I'm going to kind of handle the exceptions. So as you see, the most obvious error that would occur is the zero division error. So I'm going to say except, I'm going to say Python to accept the zero division error, and I'm going to say to accept it as error. What will happen is whenever the zero division error occurs, Python will save that object as ERR variable. So ERR will be the variable or the object that the zero division error that had occurred would be referred to. Just remember, any error that happens is kind of a Python object that is returned with kind of what the error has occurred, or where kind of the details about the error. So what we do is we kind of give it a name called ERR, and we kind of can now record what has happened. So remember, we had an error list over here. what I'm going to do is I'm going to save these values into the error list. So I'm saying error list error dot append, oops, and I'm going to say string str err. So the reason why I use this str or string casting is because error is not a string, it's kind of a object, and what I'm interested in is a string portion. So I'm going to say expected error and now things seems to be very safe, but there's a problem. When you look into the try block, you'll say that the only possible error that could occur is a division by 0, but that's not true. There are a whole lot of other errors that can happen in a computer. For example, your computer can go out of memory, and that could cause an error. So it's kind of a good idea to have a general error handling included as well. So I say except exception, and I say as err once again, and I say error list dot append unexpected error, and I'm going to convert it to a string and save it in our error list. So the thing is, exception is the mother of all errors or exceptions, and every exception is kind of derived from exception. So exception has the ability to handle almost all errors, but the thing is, when you consider some problems, like in some situations you have to handle each and every error separately. For example, if this try block generates two types of errors, and if you're going to lock these two types of error in two different documents, we'll have to address them separately. But if not, if we are only interested in preventing the program from exiting, we can just be happy with this except exception block. So I generally prefer to handle all known errors separately, and in case something unexpected happens, I'll use this block to be more safe. So you can use whatever you like depending on your requirement. Just make sure the code does not exit unexpectedly. So we handled almost all the errors, and now we can use the else block. And the else block, what it will do is, if there's been no error over here, it will kind of pop into the else block, and what we can do is we are going to save the result over here. So I'll say result equals result list dot append, and I'm going to save val. So if there hasn't been an error, I'm kind of going to save the value of the result into the result list. Right, okay, I didn't expect it, but it just happened. Now if you look into the output, you'll kind of see, if you just go to the previous example, we started with -20 and ended with -100. That is when I is -5, it's -20, and when I is -1, it's -100. But when you come over here, we have when I is -5, it's -20, and when I is -1, it's -100, and thereafter it has continued by skipping the zero division error. So what actually has happened is that it hasn't skipped it, but whenever it caused a zero division error, it stopped over there and it checked if it has been handled. So over here we have the zero division error, and once I was 0, it caused an exception, and what it did was it kind of jumped over here and executed the line that zero division error handling has been having under it. And if zero division error is not the error that has been encountered, it would have gone to this exception because it's kind of general to all errors, and it would have been handled over here. So generally this type of block is kind of very safe because of this exception part, and it will be always handled. So it kind of skipped the division by 0 and continued from there on. Now if we look into our error list, you see we have an unexpected error, which is a division by 0. So in case if there was some other error, let's say out of memory, you also find it over here. So I have plenty of RAM at my laptop at the moment. No out of memory exceptions have been occurred. So well, you don't see any error like that. Those type of errors are kind of very rare. And I think I forgot to tell you, normally when you're writing a program, anything serious other than just a calculator or something like that, it's kind of good that you save all these errors into a file. Not only errors, whenever you do something serious in your program, it's good to kind of keep them in a log file. You know, the date and time it has been done, what type of error it has occurred, and likewise. Because this type of data is kind of useful when it comes to future optimizing, error handling or debugging, things like that. And well, that's something I have from experience. Well, I don't think I have anything else to say about exceptions in Python. I hope exception handling has been a little bit clear to you, or at least you know what exception handling is, and now you can write a program that will not exist because of exceptions. Well, let's see again in another tutorial. I'm going to end it over here. Have a nice day. Thank you for stopping by.